I do resin 3D printing, but I had something come up which needed a filament printer and a load of filament. That fell through, as everything always does. Figured I'd try and make some use out of all the money I wasted. I have a few Raspberry Pis laying around, a 3B4 and a 5. 5 is recommended to be used with an active cooler. It's a 3cm fan and it's pretty cheap. I have a bunch of old computers laying around with 12cm fans. Figured I'd put everything together, run some stress tests on the Pi5 and see if it makes any difference to the cooling. I came up with 2 designs. This is the first. I printed it, but since realised it's over-engineered rubbish. These slats in the middle are for additional cooling underneath. These cylinders are for mounting the Pi. The hooks next to them are for a clamping system I designed. There are some clamps which latch onto the Pi to hold it in place. I didn't 3D print them because I realised they would just break. The Pi doesn't need to be clamped in place, we're not going jogging with it. It just needs simple pins to hold it in place, so if you accidentally knock it, it doesn't fall out. The fan sits on top. These 4 holes, I do have a screw design for them, but I gave up on that as well. It's more simpler just to use twist ties. If you've ever bought anything online, you should have a decent collection of twist ties. Or use elastic bands. Both are far more reliable than anything 3D printed. The open case design is for better airflow. We want the air to hit the board and disperse outwards. We don't want the air coming back up, which I believe is going to be a problem with my second design. This comprises of 2 parts because it has a funnel system which is quite close to the Pi and we need to be able to get the Pi in and out. The base is being stripped down and simplified a bit so you don't have to spend so much time printing. The hooks have been removed and replaced with simple pins. The funnel sits on top. You put your fan on top of the funnel, cable tie them all together. I believe the problem with this design will be the hole at the bottom of the funnel isn't big enough for the volume of air being forced through it. Pretty sure the cold air will be forced back up through the fan. I can test this by holding my hand over the top of the fan. If I feel cold air, then it's being forced back up. The idea was to try and focus the airflow onto the core of the board. The last thing to figure out is getting power to the fan. The Pi can't output the 12 volts needed to run these 12cm fans at max speed. If we're not running at max speed, then what's the point? In one of my boxes of useless electronics, I have a universal AC plug-in adapter. This has a little switch where I can go from 3 to 4.5, 5, 6, 7.5, 9 and 12 volts. Hooking it up to the fan is as complex as you want it to be. Strip the wires off your fan. Black one is negative, the other one is positive. Negative goes on the outside of the connector, positive on the inside. You should see your fan spinning. There's not much that can go wrong. If there's not enough voltage, the fan won't spin. Too much voltage and it'll either burn itself out or you blow the bearings. It won't catch fire and explode, it'll just stop working. For the sake of this video, I'm just taping the wires to the plug. It's not the prettiest thing, but if it works, we can figure out the rest another day. I'll be running a few different scenarios, stress testing the CPU with PyChart. I did try CPU burn, but PyChart was generating more heat. The scenarios are the official 3cm fan running at variable speed. If the Pi gets hot, the system will automatically increase fan speed. Can't really do variable speed on the 12cm fans because they don't hook into the Pi. There are ways of doing it, not interested at the moment. Scenario 2 is using the 12cm low riser design. Scenario 3 is using the funnel design. And the final scenario is using a combination of the 3cm fan with the 12cm fan. I'm using the funnel enclosure without the funnel. There aren't going to be any fancy graphs or reports. I'll run the load tests, leave them for about 10 minutes until the temperatures stabilise, and talk through the results. Don't read too much into the initial temperatures. I don't know why they're all so different. The footage has been sped up by 5000%. There's no point sitting here watching it for 10 minutes. These are the final stats. These red bars on the temperature for scenario 1 show the system is not having a good time. We can see the system is being throttled, and this was the only scenario where it was. 80000 means the system has been throttled. 80008 means the system is currently being throttled, which is why the CPU temperature is showing grey and red bars. Scenario 2 with the low fan riser appears to be the best cooling solution. Obviously these temperatures fluctuate up and down by a degree or two. These are the average temperatures that I saw. That's 17 degrees colder with a crappy 3D printed enclosure and a 20-year-old 12cm desktop fan. The funnel enclosure performed as I expected. Holding my hand over the top of it, I could feel a lot more cold air rising. Therefore the airflow is being restricted. It's only 2 degrees warmer than the low riser, and it's not being thermally throttled, so it's not the end of the world. The fan being raised higher from the board due to the funnel may also have something to do with it. Scenario 4 didn't perform as expected. I figured it would perform at least as well as the low riser. Instead, it was the warmest out of all 3 12cm tests. The official 3cm fan runs at a variable speed which the system controls. If the CPU is too hot, it'll spin faster. The CPU was only running in the high 60s, so the fan was only running at about 6,500. In scenario 1, fan speed was running at around 9,200. I could set the 3cm fan to run at full speed all the time, but then we'd have noise issues. I don't have a problem with desktop fans, they just make a low-pitched hum. When running at full speed, the small 3cm fans make a high-pitched whine. I don't like that. Given the system isn't being thermally throttled, there's no reason to run both fans. If you're interested in a better cooling solution, I'd recommend scenario 2, 12cm fan on a design similar to my low riser. If you're worried about noise or you just simply want an adjustable fan, they do make 12cm fans with little switches in where you can set low, medium and high. Maybe invest in one of those. Or if you're into electronics, I'm sure you could come up with something more complicated. I'm not good with electronics and I want to go to bed. I'm going to bed.